There are two Prelab assignments. One of them is to go to plot.ly. That website is just a graphing tool. You should sign up for it. Just use any email address with this tool here. I suggest that you not use the Google tool because it doesn't work sometimes. I tried that. If it works for you, that's great, but I had to do something else. So I created just any old password with any old email address that I had. After you sign in, oftentimes they'll show you some tour of the website. You could do that if you want, but what we really just need is a new project. We'll be working with Table 3, the data at the bottom of page 5-10. When you see the grid here, this is called the grid, like that. Make sure that your name is showing up here, because I will ask for a screenshot of this grid when you've done your data entry here, and I want to see your name on that on the page here. So the data is just you just copy it from page 5-10, the bottom of the page. There's table 3. The horizontal x-axis, or the x-axis, will be the atomic mass data. So I'm just copying that in here. I want you to do the same thing. It seems repetitive, but I just want to make sure that everyone knows how to do this, you know? And that's why this is the pre-lab activity. Also, I don't want you to spend time in the lab trying to graph this data by hand. That's ridiculous. Okay, so this is the y-axis data, the vertical axis data, and on table 3 from the lab manual, page 5-10, it's called specific heat capacity. So now I'm going to take a screenshot of this whole screen here, including my name there. Okay, so you will do it in the way that is suitable for your operating system, and I'm doing it in this way. I'm grabbing the current window and I'm taking the screenshot, and okay, there's the screenshot. It shows my name. Oh, I'm sorry. The screenshot shows my name right there, and it shows the data that I've entered. So I save that as Glenn1. All right, save that. And I'm going to upload that to Moodle later on. And now I'm going to draw the graph. So to draw the graph, you need to change this plot in the left frame to scatter plot. And then you need to scroll down here, go down here, where the button is called scatter plot now, and I just tap on that button, and here is the plot. Am I done? No. It's important to have, every graph needs to have a title. I will use the same title as table 3 has in the lab manual. You could use whatever title you think would be appropriate. For example, you may just want to make the title number 5 on page 511, you know? Or you may want to say graph for number 5, you know, whatever you think is appropriate. For me, I like this title. Right now, it's very important also to name the x-axis. For us, it's atomic mass, and the units. You have to include the units. That's very important. Otherwise, I wouldn't know what you were talking about unless I'm the one who made the assignment. Which I am, but I think it's a great habit to always make it clear to people what your units are and what your axes are. Okay, it's important to have the units. You don't have to type them in exactly as I've typed them in. They use the -1 power on table 3, so you could use that if you could figure out how to make that show up on the screen. Now, the problem number 5 is what I want you to do. And it doesn't just say graph this. It also says guess the specific heat capacity for the metal that is called strontium using your graph. Okay, so these are atomic masses. Now, if you want the atomic mass for strontium, if you can get that by asking Google. Please don't ask Google specific heat capacity. I mean, you can, but I want you to figure it out using the graph. But you should ask Google what is strontium's atomic mass. That's one way to get atomic mass of things. Of course, that's not the best way. The best way is to use the periodic table, right? Because when you take the exam in this class, which will be on the 21st of March, I think, you don't get Google, but you do get a periodic table. And on the periodic table, usually there are atomic masses. Let me show you where to get it. Here is strontium, and wow, this periodic table doesn't have atomic masses. Most of them do. Let's see. I need a periodic table that has atomic masses. This one probably has atomic masses. So here is strontium, and you could see here that the atomic mass is 87.62. This is the average atomic mass that I showed you how to calculate on Saturday. It is the combination of all the relative atomic mass percents of all the isotopes of strontium. But anyways, the average atomic mass is 87.62, so that's what we'll use. I'll just put this aside. So the atomic mass is on the x-axis, so I'm looking for 87.62. If I make this window active, as I go along here, it's hard to see where 87.62 is going to be in between 50 and 100. But I have a way to do that. So first of all, there's 50 to 100, and in the middle is 75. So you can just sort of guess that 87.62 would be somewhere around here, and that would mean if you were to imagine a line for these dots, you know, 87.62 might be somewhere around here on that line. How would you guess the specific heat capacity for strontium, which weighs 87.62 atomic mass units? Well, you would just draw a straight line horizontally all the way to the y-axis from that point, and right there. It's somewhere around there. So that this is 0.2, this is 0.4, so it might be 0.3 something, or maybe 0.2 something, something like that. Here's a better way to draw that line. If you say that 87.62 is like somewhere around here, then you can just put your finger right there on the screen, and then take any old window and use its upper edge as a ruler, you know? So I'm just using this other browser window to draw a straight line from here all the way over to here, and I see that it's 0.2 something, or maybe 0.3, something like that. It's okay to just give me one significant figure for your estimation of the specific heat capacity of strontium. All right. Now, for extra credit, instead of guessing at the specific heat capacity of strontium, I'd like you to do the following. This is worth 5 points of extra credit for this lab. You go to the button called Fit Data. Tap on that button. Add fit to this trace. Change the function to inverse, because this is an inverse graph. Okay? And you get this equation. This is y equals some number, that number goes here, plus some other number, that number goes here, and divide that other number by x. X is the atomic mass, okay? Where y is the specific heat capacity, right there. That's y, specific heat capacity. So you tap on run this fit. You know, you don't enter any numbers. The software will do it for you. And boom, you have this nice line. You see, this line is not a dot to dot connect the dots deal here. Connecting the dots is a line graph, and that is not what this is. This line is the graph of a mathematical function. If you tap on the edit fit button here, you get the function. There it is again. Specific heat capacity is f of x, and that equals this number, there it is, a new number there, plus that number divided by whatever atomic mass you have. So if you plug in the atomic mass for x and do this on your calculator using that number and that number, then you will get y. Y is the specific heat capacity. That's the best way to estimate what is the specific heat capacity of strontium using these data. So please do that and take a screenshot of this equation, this number, and this curve. So in other words, take a screenshot of this whole thing. When I see that this is on your screenshot, and when I see that you have used this equation to estimate the atomic mass of strontium, you'll get the extra credit. So here we are. I'm going to take the screenshot, and I grab the current window. Everyone has a different kind of computer, right? So you won't use exactly the same screenshot method that I'm using. You see that there is the equation, and very tiny there, and there's the curve. All right, so then I'm getting extra credit. So this is Glenn's extra credit. Okay, and I will upload that to Moodle also later. So in the Moodle assignment, there are two things to upload. There was the screenshot of this data right here, and there's the screenshot of this curve. And if you wanted the extra credit, then you're also adding this into that same screenshot. You're adding the equation. There it is. You're adding that into the same screenshot. Just in case you need the extra help, let me show you how to upload these things to the Moodle for your Prelab points. I go down to the Prelab assignment, problem 5. Oh, this is actually problem 4. Sorry about that. That's a typo. I'll change that. But when you find it, you can use this link, or you could use the purple link with the online guy icon, and then you're going to want to add a submission, and then you can add a file here and find the file that you made, your screenshot. Let's see. Where did I put my screenshot? Not sure. Ah, there it is. There's my extra credit screenshot there. I upload that file, and I add another file, and I get my data screenshot there. Upload that file. Okay, so there's my data, and there's my extra credit. Save changes, and that's it. That is it for this Prelab assignment. I know what you're thinking. You're thinking, where do I enter my estimate for the specific heat capacity of strontium? Well, that won't be in this Prelab assignment. There will be another Prelab assignment, which is a multiple choice or short answer type of deal, like last time, like the Prelab for last week, and there will be a spot in there for you to enter your estimate. Okay, you can just use one or two significant figures. You don't have to use any more than that. Thank you.